Welcome, friends. My name is Will, and I'm one of the instructors here at Coding Dojo. I am the Azure specialist, if you will. So I help run and choreograph all of these Azure workshops. Today, we're going to be doing our Azure AI-900 fundamentals sort of workshop, and this is going to prepare you for the Azure AI-900 fundamentals, or the AI-900, certification and exam, which is a really coveted exam. It focuses on AI. Obviously, it's in the name. So there's quite a few things about that we're going to talk about before we sort of jump into the actual material. We're going to do a welcome. We're going to talk about the actual exam, and then we will jump in learning and kind of walking through what this looks like. A couple of ground rules before we get started. Teamwork makes the dream work. We're going to be working in groups. We're going to be working with people. So having humility in that is going to be huge. There might be some stuff off the gate that you don't understand, especially if you come from the web development side. This certification does deal with some machine learning and the pipelines and what that looks like and how the machine learning process goes through. And that's what we're going to be learning today. So maybe at the beginning, it might be a struggle, but I promise that if you stay with it and ask good questions, you will be A-okay there. And then obviously respecting yourself, respecting me and your fellow students. Right. If you have a loud surrounding, please, mute your mic, or if somebody's talking, please don't talk over them or just interrupt. Anything like that is really, really helpful for the learning process. A little bit of housekeeping. Now, this is a broad schedule. Usually we end, I promise we won't stay probably past 4 p.m. I've never done a workshop that has stayed past 4 p.m. But we just keep that just in case, there's a lot of questions or, XYZ, there's a lot of things that sort of go on. Then we just want to make sure we have that time blocked off, but we will be from 9 to usually about 11:30, 12. We're going to do our morning session. We'll have lunch, and then we have our afternoon session. Again, we put a 30-minute buffer in the morning session because we are going to be going over the machine learning process. And so if there are extra questions on that, then as always, we can have that time to sort of answer those. So in this workshop, we're going to be learning about core AI concepts. I just want to say this is my favorite workshop to do for all of Azure. It's really, really cool seeing the AI and seeing the things that you can do with it. It's really, really cool. So we're going to see what the concepts are, AI workloads in Azure, so what it looks like to set that up in Azure, and then the different services that Azure specifically offers. Now, there are multiple cloud platforms, right? Microsoft's is called Azure. There's Amazon is AWS, and Google is GCP. And there's other small ones, but those are sort of the big three. And the things that separate them is the services, the tools that each individual cloud has, right? The actual applications that you can use, the different things that Azure offers compared to AWS. And we're going to be learning about those, especially in the back half of today. We're going to be seeing a lot of really cool things with like computer vision and natural language processing, a lot of really, really cool tools that you can build. And I'll give you a real world example of how I used Azure to build out, an application. And it's a really cool thing that you can just have in your belt, and you can build really powerful things very quickly. So once you do this workshop and you do a little bit of studying, this is going to get you about 85% of the way there. And then from there, then you will, need to do a little bit of self-study and just make sure you're reinforcing the concepts, and you'll be ready for the exam. And once you take that and you pass it, you can showcase it. You can put it on your resume, your LinkedIn profile, your social media. And so especially your LinkedIn profile, that's one that I would say you really, really, really want to put it on there, because when recruiters are looking through your LinkedIn, they're going to see this certification. And it's going to say, oh, okay, not only do they, know how to code, but then they also have understanding of tools and they have experience working with Azure. So it will really help boost sort of your value as a developer. I also in the chat put the slides. So if you did want to follow along with me, or you did want to ever click on some of these, like here's a source that shows that Azure is actually on the rise, and companies are wanting to use Azure more. So if you wanted to do that, it is right here. And so the link is in the chat for that. Cool. Again, some of the learning objectives are to prepare us for the AI-900 exam. Once that certification happens, you will be, one more step closer to being able to get a job, or, look better and get in front of some recruiters. In this, again, we're going to learn what AI even is, just from a fundamental standpoint, and just some core concepts of that. We're not going to go in depth of, how do you build a natural language processing, application. We're not going to go in depth of like, how do you build computer vision, but we're going to say, how do we utilize these tools in the applications we're already building? Because that's typically what's going to happen, right? Especially if you're at a startup, if you're at a company, the energy and the power and the time of building your own versus just utilizing a tool that's already built, that's probably going to be better than what you can build on your own, because Microsoft has all these tools and all this energy to put in, is going to be really beneficial. So we're going to learn some of that. And then we're going to learn, again, the specific offerings and the different types of AI. Upon finishing this, so whenever you guys, towards the end of the afternoon, I will be taking sort of attendance, if you will, basically just jotting down who stayed throughout, because it does require, at least I'm pretty flexible. If you have to leave at the end, 30 minutes before, you have to pick up your kiddo, or, something happens, you have a doctor's appointment, you have to miss an hour, I'm super duper flexible. Just make sure that you message me, just private message me in the chat and let me know. I'm not going to, if you're not there towards at the very end, I'm not crazy like that. But at the end, if you do stay for I would say, 3/4 of the majority, 7/8 of the workshop, then you will qualify for a 50% off voucher. Now, this voucher is valued at $50. And the reason I say that is because the exam itself is $100, but this voucher is basically just a $50 credit. There are other exams that you can take that are more expensive, right? So let's say you've already taken the AZ-900 and you want to take the AZ, I think it's like 100. That one does cost more than $100. So it's not going to be 50% off if you did want to use this. And you can use these coupon codes on different ones. So it doesn't have to be just AI-900, but it's just a $50 savings. So if the other exam is 150, let's say, it's not going to take it down to 75. It's just going to take it down to 100. So it is worth $50, but the AI-900 certification is $100. And so this is a 50% off voucher towards that. So again, this is just from the Learn platform, the Microsoft Learn platform, sorry. And so you're going to take the exam, and then you'll get something that says like a certification, it's certified, and then you can post this badge onto your LinkedIn. It does the exam, just a little bit about it. It's about 90 minutes. It is proctored as well, meaning that it can be done from your home, but somebody will be watching you. So they want to make sure that you are not cheating. That's sort of what gives validity. That's not sort of what gives, that is what gives validity to the certification, right? It shows that you are capable of actually understanding this material without Googling, without, just finding the answer somewhere else, but you and your brain know how to use these and what tools it is. That's what gives validity, and that's what gives sort of power to the certification. Not to say things like the LinkedIn certification isn't great, that's good to go, but, sort of anybody can be at home and Google and so get quote unquote certified. But this one is proctored, no notes. You do have to show like your desk. You have to show and make sure that, you don't have other technologies around you. So it is sort of more intense there. It's anywhere from 50 to 60 questions. Excuse me. It is anywhere from 50 to 60 questions. I think I've seen like 55 is typically the normal one. And you do schedule it in advance because it is proctored. It means another human must sort of be scheduled at a time that is beneficial for you. Now, I've seen times all over. So it's, not that it's only 9 to 5 PST or anything like that. And usually you can do within 24 hours, but I would say schedule a week in advance at the earliest. Schedule a week in advance just to make sure that your time, that you need is available and ready. A day before can be kind of difficult. Here's a format of what the exam looks like. You're gonna, and this comes again, just directly from Microsoft itself, where you have to describe AI workloads and considerations, about 20% of that. We're going to learn all of this today too. And the morning is going to be really the first 2, and then the afternoon is the last 3. And then the real main piece, and this is why we focus on this in the workshop, is to describe fundamental principles of machine learning on Azure. It's about 30 to 35%. So it is a heavier workload, and we're going to talk all about that. Talk about computer vision workloads, what that looks like, the processes and the services that are provided, Same thing with NLP and then conversational AI. All of those are going to be, that's sort of the fun part for me, because then you can see really the tools and the things that the computer can do and the tools that you just have really accessible to you. Right now at Coding Dojo, we offer 3 exam and certification workshops. Our AZ-900, that's our base sort of cloud one where you learn fundamentals of the cloud. What does that look like? That's also our largest certification, meaning the material in order to get certified. There's quite a bit of material. Then we offer the AI-900. Obviously, that's where we're at. And then the DP-900 is our data science focused. Now, I would say though, or I guess I'll say data focused, because I would say that these blue and green circles are sort of misleading. If you come from the data science team or program, you know that AI is a big portion of that. So really this could have, a green circle around it as well, and vice versa. This data fundamentals, which will be next week as well. There is, just like David said in the chat, there's lots of overlap because you're dealing with that whole certification process is how do you deal with relational and non-relational data within a database. And so if you've taken, obviously, if you're on the web development side, you've dealt with data and you've dealt with databases, both relational and non-relational, if you did MERN in either Python or Java or C#. And so there is lots of overlap. And I think all of them give you just a greater understanding, whether you're a developer of like web applications or you're going into data science. I think even having an understanding of cloud fundamentals and what the cloud looks like and why the cloud works is a helpful thing. So all of these, I would say, is sort of just overlapped, intertwined to where anybody, whether it's web development or data science, is going to benefit from taking any of these certifications. The only one maybe would be cybersecurity. I don't know that you would necessarily need that if you were in the cybersecurity sector, but we don't have anybody there currently. There are, like I said, other certifications. There's the AZ Security Engineer Associate. That's a great one for cybersecurity. Administrator, AI Engineer, or Engineer Associate. That's sort of the next step. A lot of these are the next step stuff. Data Scientist Associate, Data Engineer Associate, Data Analyst Associate. Those are all the next steps. So I would say start with your AZ-900, your AI-900, or DP-900, and then sort of move forward. But again, if you really find one, you're like, I want to learn everything about AI. You take all 3 workshops with us. You have 3 coupon codes. You go, nope, I'm just going to dive into AI. You absolutely can use one. You can only use one. You can't stack, unfortunately, but you can use one to take off $50 towards like the AI Engineer Associate, if that's something that you're interested in. There's a little bit of learning path for this. Again, we're going to be talking about, and this is sort of the path that we're learning, workloads and considerations, what that looks like, fundamental principles of machine learning. That's, again, these 2 are this morning. And then these 3 are going to be this afternoon. And then you will be ready. Again, we will be about 85% of the way there, maybe even 90%. There's a cool little practice test that we will show you that really, if I were you, spend the $12, get it to make sure that you are a one and done sort of person. And you don't have to retake the exam because you don't get another coupon code if you have to retake, sort of thing. So, and then you'll be there and you'll be ready to be certified. Again, here's some resources. Just want to introduce this to you. This is the Microsoft Learn platform. We build our workshops based off of the exams that we've taken and the Learn platform. So this is a more in-depth, I would say, probably if you wanted to sort of learn, this is another in-depth thing. This is everything that comes from the certification. Every question on the certification comes from this material. So you can, it's not super duper thick, but you can sort of get started with this. And I would say that this would be definitely part of your personal learning, is going through this and just making sure that you have this ingrained in you of what these, what is computer vision? What is conversational AI, challenges and risks? What is responsible AI? That's a huge one. We're going to be doing actually a group project of responsible AI here in just a bit. So understanding this, but really just wanted to get you familiar with the platform, and all of these links have it here to where you can, go and check it out. If we go back one more, there's also just this guy. This is the AI-900. This is where you'll actually sign up for your exam, to where you can sign up for the certification. This is the certification dashboard. You click on that guy. Oh, sorry, that's the wrong thing, not the certification dashboard. But here's where you can sign up for your exam right here. You just schedule with Pearson VUE. We'll go over this at the end. But you schedule here, and then this is how you'll sign up, and then you'll put in the coupon code. But we'll focus on that. And these are the 4 sections or 5 sections, sorry, that they're really walking through, and it's not too much of a lift. I mean, this one has 1 module, 4, 6, 4, and then 1. So it's not a ton. Again, if you've already taken the AZ-900, it's much, much more robust. Cool. Again, tentative schedule. I had it marked down for 9 to 10 to be our introduction, but that just was our introduction. So yeah, much, much easier. It's only 9:22. In just a second, we're going to do an intro to AI. I'm going to ask, if there's any questions. And if there's not, we'll do an intro to AI, do our group exercise, have a quick break. Then we're going to really go through our machine learning. This is the bulk of the learning today, probably the most like the thickest, if you will, piece where we go through the process of machine learning. We'll do a group exercise, probably as a holistic group, make sure that we have an understanding, and then we'll go to lunch. Cool. Also, want to put this in the chat as well. This is a study guide. You do not have to use this. This is solely for your, your studies. If you want to use this, you totally can. It's just a study guide. If you're the type of person that's like, man, if I just sit and listen to Will all day, I'm going to never retain anything. This is just another way that you can sort of have some key things and then type in, or maybe go back through if you want, and sort of fill this out as you're studying and preparing. The one thing I will say, no, we're going to start at 1. Sorry, somebody in the chat asked if it's going to start at 1:30. We will start at 1. So I promise we will be done by 12. So you can schedule that. This right here, you will not be able to edit it. The only way to edit it is you go here and you go make a copy. When you make a copy, then you can edit that one. So this one obviously is our company one. So I can edit, but you guys won't be able to. And so go ahead and make a copy of this. There's going to be a couple things throughout this workshop that you'll do the same process. You go file, make a copy, and then you'll be able to edit your copy. So go ahead and do that if you want. Again, this is just solely for your learning. Just that way you are, sort of set up the best, if that's the way you like to study. Any questions for the walkthrough, for introduction, anything on the exam or sort of today's schedule, anything like that? Great question though in the chat. I would say if you're planning the afternoon for, a meeting in the afternoon, we will start at 1 o'clock. Every workshop I've done has been done by 12 for the morning piece. Plus we're already 30 minutes ahead of schedule, so should be good to go. Any other questions, friends? Feel free to unmute or put it in the chat. Well, that's all right. Also, did just want to give a heads up. I do have 2 dogs, so sometimes if you do hear, I'm in my upstairs loft right now. But if you ever hear, barking, just let me know if it's distracting, and I can make sure I take care of it. Cool. All right. So we're going to do an intro to AI, and we're going to really start talking about what is AI, what is artificial intelligence, what does that look like. But before we even get started into our intro section, I just wanted to ask, does anybody know what Azure is? I kind of touched on it a little bit earlier, but does anybody know what Azure is? You need to put in the chat. Feel free to come off mute. Sorry, this is not a rhetorical question. Like, can you describe what Azure is? Yep, somebody in the chat put a Microsoft cloud platform. Okay. Anybody else have anything? Again, feel free to come off. Yeah, global network of data centers. Yeah, exactly. Right. So Azure is Microsoft's cloud. It's data centers that have services that either we could host our application or we can use tools for Azure. It's a whole sort of smorgasbord of tools that developers can use and companies can use to better their applications. According to Wikipedia, this would be the definition is Azure is a cloud computing service created by Microsoft for building, testing, deploying, and managing applications and services through Microsoft managed data centers. So Marwa, right on the head. Way to go there. AI. Does anybody know what AI is? Could you describe AI for me? Maybe even what AI stands for. Again, feel free to come off mute. This workshop will be better if we're
it's artificial intelligence or smart machine learning, essentially.
Yeah, exactly. So AI, or artificial, way to go, David. Thank you for coming off mute for that.
No worries.
Is artificial intelligence. It enables us to build amazing software that we can improve healthcare, enable people, and overcome physical disadvantages, empower smart infrastructure, create incredible entertainment experiences, and even save the planet. If you guys really think about it, AI is everywhere. And I heard a really great quote. This is why I love A, this certification, and B, I'm just obsessed sort of with AI. Great quote was, in the next 5 years, every company needs to be a tech company. And I just think that's such a fascinating concept. But the idea is if in 5 years, your company is not using tools that are predictive modeling for either sales or purchasing, or, if you're not using AI, you will be left behind. And I think that's a great thing for us, right, as developers, because that's like, hey, job security. Now every company is going to need AI, or a company is going to hire another company to do their data science or their AI or data analytics or anything like that. And right now, AI is so ingratiated to our culture already that it's, I have a friend who works in business. She works I'm in Seattle area, and she works for Nordstrom, the retail company, I guess. And that's literally, she's a business analyst. That's what she does. Business analyst for the big VP people, like the higher ups. And they use predictive modeling all the time. And every summer they do the Nordstrom sale. And right the week after they are done with the sale, they take the data of that year and they start doing predictive analytics, and they start predicting next year's sales. And they can add in, if I do this, then what is it going to be? Right? That's already happening with some of the biggest companies. And so data science, and when I say data science is typically the umbrella that AI falls under. So even in our program, data science is that's where you will learn moderate and advanced machine learning, which is sort of artificial intelligence, right? So machine learning is where you can do these predictions and you can do all sorts of things. And that's on the rise right now, right? So many companies, whether it's through healthcare, whether it's through retail, whether it's through the markets, and fintech is huge right now. If you could predict what a stock is going to do, and you can buy and sell at buy at the dip and sell at the top, like, oh, you'll be richer than Warren Buffett, right? And so AI is doing all of these things for us. And it can do so many things, whether it's through healthcare, detecting cancer, or we'll see where there's a great video that Microsoft has where somebody has a physical disability or disadvantage, and AI helps them operate out in the world. It's really, really cool. So here, let me share I just love this one. Let me share my sound, and then let's watch this video. I don't think this is the one. Oh, this is just a cool one about AI.
Artificial intelligence isn't coming, it's here. It's the defining technology of our time. But it's human ingenuity that makes it so powerful. Jane started losing her vision when she was 12.
California Street.
She uses Seeing AI.
I crept down
the stairs and out the door,
which enables her to read and navigate her world. Microsoft AI is helping farmers adapt to climate change.
We can use technology to help feed the world without wrecking the planet.
Enabling wildlife conservation.
The ability to use AI really democratizes science. WildMe uses images from any source to help study endangered species.
And creating new ways for people with hearing loss to communicate.
I want the exact same information that my hearing friends have.
It's more than just imitating intelligence or sounding like a human. Microsoft AI is changing every industry, from healthcare.
And now you can see these finite details, the relationship with many structures.
To engineering. And telecommunications.
We are using artificial intelligence to change the way we are relating to customers.
AI lets us put people first. The Microsoft tools really enabled us to breathe digital life into an iconic brand persona.
The product that we make is not a thing in a box. Microsoft AI empowers others to create experiences and potential. This is just the beginning.
Artificial intelligence, it's just opened up this whole world.
The future we invent is a choice we make.
I don't know if that hypes you up as much as I get hyped, but artificial intelligence can change everything. And I think it is such a cool thing. So simply put, AI is the creation of software that imitates human beings' behavior and capabilities, oftentimes even more efficiently and better, right? Humans can predict a lot of things, but using, millions of data points is going to help that prediction even more. So AI is, sort of on the path to bettering and bettering human predictions, even, if you will. That's where the whole scare of iRobot comes from. But we're kind of there, but then still far away from that. So whenever we're talking about AI, that's such a general term. There's quite a few things that are associated, and this is not a a widely accepted, this isn't like from a data science perspective. This is from Microsoft's perspective. And from Microsoft, there are, here are the key elements of AI through their lens. And it's machine learning, which we're going to talk about today, anomaly detection, computer vision, natural language processing, and conversational AI. Again, machine learning is going to be sort of this foundation for, it's often the foundation for an AI system. It's the way we teach a machine, right? If a machine is wanting to look for cancer, then is this tumor benign or malignant, right? We teach it, okay, this is a malignant tumor, this is a benign tumor, and we teach it, and it learns through tons of data points, which is which, so that way whenever we actually need it to make a prediction, it can say, based off of all my understanding, this is malignant or benign. So that's sort of what machine learning is. It's teaching our machine what certain things are. Then there's anomaly detection. So this is capability to automatically detect errors or unusual activity in a system. A great example of anomaly detection would be your credit card company, right? I don't know about you, but sometimes hopefully it's not often, but I'll get a call and say, hey, did you just make a purchase in the UK, right? Well, if I made a purchase, let's say I live in Seattle, let's say I make a purchase at 1 p.m. at my local coffee shop. And then at 2:30 p.m., a purchase is made at a coffee shop in London, right? There's not somebody sitting and watching every transaction and saying, what's the travel time between Seattle and London? Could it be an hour and a half, right? Could this person make both purchases? No, right? There's a system that is detecting anomaly, and they're saying, oh, that doesn't make sense. Let's reach out to the customer and say, did you just make this purchase? If not, then your card's compromised and somebody tried using it, et cetera, et cetera. So that'd be an idea behind anomaly detection. Then there's computer vision. So it's capability of software to detect and to interpret the world. You can think about automatic driving, right? Autonomous driving, Tesla, right? Through using camera, video, and images, it's detecting this is what this whole idea behind autonomous driving is. Then there's natural language processing. This one is one of my favorites because I think it gives people from all over the world the ability to communicate, and that's something I'm really passionate about. So it's capability for a computer to interpret or interpret written or spoken language and respond in kind. There's a cool tool that people are starting to build, and a tool that I'm building using actually Microsoft's speech to text idea, and it's going to do this exact same thing. Then there's conversational AI, which this is the bane of my existence, if I'm being blatantly honest. It's where companies are using conversational bots, right, to have a conversation instead of having to hire agents either to answer the same questions or to sort of just have a conversation, set an appointment. It can't, there are pros and cons. I have so much disdain for conversational AI, especially if you're having an issue. Like I was just having an issue with my internet 2 days ago, and it kept saying, please make sure you try doing this. And I'd already done it. And I literally lost my mind because I was like, I just want to talk to a human to get this fixed. But it can be really beneficial with repetitive tasks, something like this, right? I was talking to a friend and they make their hair appointments just through a text. They text a number and says, hey, I'd like to make an appointment, and then on this day, and then it gives a bunch of times and they text, yep, I want this time. They don't have to call, they don't have to do anything. It's just a quick text, and that's conversational AI. And so that's the umbrella of AI. And Microsoft is very passionate about, and I think everybody should be, that we have all of these technologies here, right? And it's really powerful and really neat, but we've got to be responsible for our AI. And it's because artificial intelligence is a powerful tool that can be used greatly to benefit the world, right? That video just showed, whether it's through food or through helping people with physical disadvantages, it can be very, very, very powerful. But like any tool, it's got to be used responsibly. So Microsoft and the AI software development is guided by 6 principles designed to ensure that AI applications provide amazing solutions to difficult problems without any unintended or negative consequences. And so what we're going to be doing is doing a group exercise. So I'm going to split us up in 2 groups. And here's what the exercise is going to be. I'll put this in the chat as well. Only one person from each group is going to need to basically what you will do is I'm going to put you in groups of 4. And so there's going to be 1, 2, 3, 4, 5, 6. So I would say just divide it amongst your group, who's doing 2 and who's doing 1. But what you're going to be doing is you're going to take this project, you're going to go make a copy, entire presentation. And so make sure you do that. Only one person from your group needs to do that, not everybody. Only one person needs to do that. And then what you'll do is once you divvy up who's going to be doing what, you will look at the material. So there's a link right here to the actual docs for all the material. And basically, simply, you can delete the slide, you can make a new slide, but just sort of teach us about what is accountability? What's an example of that? So make sure you include at least one real world example of what accountability would look like. So it's just a quick thing about teaching. Okay, so let's go down wherever accountability here. Here's a video, so you'll watch this. And then people should be accountable for AI. Systems designers and developers of AI-based solutions work within a government, a framework of governance, et cetera, et cetera. So sort of teach us about that and what would be an example of that. So again, you will be split up into groups of 4. And so you guys will divvy this up. We'll give it about 20 minutes to do this. Divvy it up. You walk through it, create a slide, and then what we'll do is we're going to come together and then talk about this and even think of some more examples so that we really understand what is responsible AI, because this is a very, 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 very powerful tool. But I think we've seen, there's really powerful tools in the hands. That's where wars and all this other stuff starts. So any questions on this group project? I will open the rooms now. And again, just make sure one person makes a copy and then you guys all work through that.
All right, see you guys see the right stuff here?
Yep.
Cool.
Good to go.
All right. Should I actually present this like a slideshow? I have no clue how this stuff works.
There you go.
Okay, clicking through. All right, yeah. So I just made an extra slide for each.
Yeah.
Fairness in AI, as you're saying, was mainly a socio kind of a societal challenge more than anything else. And it's, basically when AI algorithms are making decisions about things like allocation of resources, opportunities to give individuals different information, couple real world examples, college admissions, loan approvals, etc. You have to make sure that everyone is, getting fair treatment there. That can go real wrong real fast, especially in today's society. You don't want to be messing that up. So when one measure to help that could be having diverse teams, bringing different viewpoints and perspectives when working on or developing or even testing these algorithms. So
absolutely, that's that's great. And I think what we'll do, Peter, is we'll just sort of go through each one and then talk about it and then see if the other group has another one too. So I appreciate you sharing that. Hey, can you go back to that fairness slide real fast for me? This is something that right now in AI is a huge deal. There's a great, not a great, it's a terrible story, but there was a story about a year and a half ago where Google had a team that they were basically going through their AI, and they were sort of this team that was going to go through and say, yeah, this is good, or this is, just to see if their AI was fair. And it came out, one of the doctors, she had her PhD in artificial intelligence. Obviously, she worked at Google, came out and said, hey, actually, this is not fair. This is, we are biased in a bunch of different ways. And she ended up getting fired. Now there's a whole bunch of stuff like, so this is not me dragging Google through the mud because I don't want to get sued, but more so it's just this idea of there's this push, and we are seeing that technologies can be created with bias in them, right? And AI can be created if we create a bias and we only train it on, if I'm having it detect people and I only train it on people that are white, right? Then it's going to be hard if it at all will be able to detect people of color. And so we have to make sure with our AI, and we have to be responsible in saying yes. And that's where Microsoft is using their tools, right? They have been responsible to say, no, we need to train our AI to recognize all people, right? Every ethnicity and every gender. We need to be able to do that and include in it be the same field. That way, loan approvals is a huge one, right? Like a house loan approval is a big one. Another one, and it's a little bit scary when it talks about this fairness idea, is I think it's Wisconsin. There's a county that is using AI to determine if people should be let out on bail or not. And part of the issue with that, right, if you think about it, is they take in some data, like what the person, where they live, their jobs, how much money, parents, if there's a single parent or if they're an orphan, all this stuff. And then they compare it to past, and they've trained it on past felons. And they basically create a probability of, yes, they are likely to repeat offend while they're out or not. Well, if you think of America's judicial system and prison system, right? It's not a secret that it's not fair or it's not equitable in the sense of people of color are in prison or get arrested at a much, much higher rate than people who are white, right? And so we have to be aware with our AI, because if we, are just training it on all the people that are in jail, if our data in itself is skewed, it doesn't create a level of fairness, right? To where if you add in ethnicity and it's like, oh, somebody who is of color is 2 times more likely to offend. Well, that might not, the color has nothing to do with it. It's just showing that your data shows that, more people of color have been, even arrested in the first place, et cetera, et cetera. So we have to make sure that in our AI, even not only in what we use our AI for, but just in the training, right? In the inner workings of our AI, we have got to be fair, and we have to present it to where everybody feels like they are represented, and everybody has the same equitable, advantages, whether it comes to college or loan approvals, et cetera, et cetera. So great job. Did the other group have anything to add to fairness, or does anybody have anything to add to fairness?
I actually just got a question in my head. So basically, if we imagine that you created the judge, right? Actually, this is part of our group decision. We're talking about the fairness and about the judge too, but like, based on that, what you just said, okay, you're training it and you put, for example, 50% white, 50% black people, right? And I definitely don't want to sound like racist or something, but like based on, it was Martin Luther King, like in Monday, right? And Martin Luther King, actually, he has one speech. I don't remember which town he said it, but like you can Google it. And basically he went out and he's like, hey, there is like I'll say it in a nice way. So basically he's talking to his community and he's like, hey, white people, they have their flaws and stuff. But like as a black people, we should see that we are 20% of the population on the town, but we're responsible for the 80% of the crimes which are happening in that town, right? So basically, if we think about that AI, if it's working like Tesla, right? Tesla right now, whoever is driving it on the street is just like basically adding more to the AI with the time, right? So if you have more people of color going there and creating that crime, how you can adjust that properly in future?
Yeah, and that's a great point. And I think that's a much, much larger concept or topic that transparently I'm not versed on, right? Like I have no experience to speak on that. Because I think you're opening a topic of, you know, is it people of color who offend more, or is it people of color who just get arrested more, right? And I think you do that. And so I think transparently, when you're building your AI, you bring in those heads that have studied, the economists who have acknowledged and understand. And I think you search for data points as you're training it that have the same similarities. This would just be my guess. Again, this is a total guess, right? Of, okay, somebody who is white and somebody who is Hispanic and somebody who is Asian that has all of the same levels. And then what do they do, right? So like if they are two parents or one, what zip code they live in, all, you know, you want to sort of, so there's this machine learning thing called clustering.
You know how I would go about it? I'm just not gonna put that input for a race.
I'm sorry?
I'm just not gonna put that input for a race if I'm creating the AI. I'll put everything else, but not that input. I think that can actually. That
would be I mean, at the end of the day, that would be a huge step, right? Like it's, and that's the other thing too, is when you're training your model, does this model, if I'm inputting ethnicity, does it actually skew it, right? And what are some things? So there's like it's called overfitting, where you have too many things that you're doing it to where it isn't as optimal. So yeah, that would absolutely be another route to go, is just to actually not even include ethnicity would be that one. But it's just making sure, and it's not even necessarily, you know, because we don't want to always just exclude ethnicity, right? Because there might be other things too that if there's a you know, other things, whether it's like a auto approval on a college on like a college scholarship, right? And maybe part of it is they're siphoning through and you're having AI sort of filter out and say, okay, I want this to go in here. And, you know, this one is for, you know, XYZ. Maybe you have to do some sort of filtering process. But how do we make sure that that is, you know, equitable for everybody? Also, in things like fairness would be something very simple of when the iPhone came out at the very, very beginning with the face technology, right? There was an issue with people of Asian culture, right? To where it was having a harder time distinguishing. And it's because it wasn't trained on that, right? It was trained on people who are, you know, white or Hispanic or, you know, it was having that issue. And even if it was trained a little bit, it wasn't as effective. And so that's just immediately outcasting, right, a certain people group because of the way that they look, right? Because this technology is basically saying, I can't tell, I don't know who is who, right? And so if we're going to use a technology like that, we have to make sure that we are representing all cultures and all communities. Cool. And as you guys can tell, this is, I mean, we can talk about all these for the entire time, right? And talk and sit. And so this is why there's so much, and even on the exam, there is a heavy portion of the responsibility of AI, because Microsoft does take this important, because as you can tell, just even from our first one out of 6, that this can open up a can of worms, and this can be a bigger conversation that we want to make sure that we are attentive and we're aware of people's emotions and people's feelings and people feeling included. And people being included, not just feeling included, but making sure that we are creating technologies that are optimal for everybody, because that should always be our goal, especially as developers. And we'll see in natural language processing how even there's some struggles built in. So we'll see that in the afternoon. Cool. Thanks for that. Peter, can we go to the next slide?
Yep.
Cool. So this one's just reliability and safety. Does anybody want to talk about this one?
Yeah, I can talk about this one.
Cool. Thanks, Thomas.
So basically, AI systems, they need to go through rigorous testing to ensure that, they're working as designed, they provide safety to the user and also anyone that interacts with them. Because wrong assistance or predictions can lead to harm. And the biggest idea of this is, what we've seen with autonomous vehicles, if they're not safe, they're not reliable, not only do they kill the driver, anyone else on the road, they can make those bad decisions when a human, lets that machine make that decision. Another real world example is, as we're getting more into the predictive health diagnoses, if an AI is set up improperly, it could misdiagnose people, whether not catching cancer or saying someone has cancer when they don't, which can lead to unnecessary procedures, or a bigger sickness or death possibly. And then one of the biggest problems is if we do have unreliable or unsafe AI and it's released, one, it harms people, but then it also further sets back the acceptance of it, which, down the line could actually harm people more if, that technology is actually safe and us as humans just aren't accepting it because we have the perception that it's unsafe. So.
That the first ever, I think it was lawsuit, was yesterday, or it was either this morning or yesterday, was filed against a person who was killed in an autonomous vehicle. And so this is wildly important. We do have to make sure, and I think you hit it right on the head. Another great one would be diagnosing, because we are using technology to be able to diagnose if a tumor is benign or malignant. But with that, just like you said, right, if it says that it is benign, then okay, or malignant, sorry, then it's like, okay, there's going to be some further tests we have to do. The real scary thing is if you say it's benign, right, and it actually is cancer, and we say, no, it's not, people go off and they think, oh, okay, I'm good. And then it continues to grow. And then it gets to a point where, the next time they catch it, it's at stage 3 or stage 4, and it's much, much more difficult. So we do have to make sure that, because even if you think about it, if something is 99% reliable, you think, okay, that's cool, right? 99% reliable out of but if you really think about it from like a global perspective, let's say we had a technology with a technology that serviced the world, and it was to catch cancer or not, right? Well, if that's the case, out of 1 million people, even if it's 99% reliable, I think it's, I don't know, 1% of 1 million, is that 10,000? Yeah. So it's like still 10,000 people would be, okay. So out of the world, this is great. Thanks for this. Of the world population, 80 million people would still be misdiagnosed. So even at a 99% correct rate, 80 million people could be misdiagnosed. And so you can see that we have got to make sure that if we are using and relying on these tools heavily, just like you're saying, Thomas, with either autonomous cars or implementing this in the healthcare, from a global perspective, it still has massive impact. Like I think 99% accurate. I'm like, oh, that's awesome. No, it's like still 80 million people are misdiagnosed or dead, right? Because of that. So we have to make sure that our technology that we're using is wildly accurate. That's like the 99.999%. Like we have to try to get there if we're going to use these and implement these into our day-to-day life. Way to go. We can go to the next one. Anybody else have anything to add on reliability and safety questions? Cool. We can go to the next one. Cool. So this one's privacy and security. Anybody want to talk about this one?
This is the one I did if the other group doesn't have something they want to talk about. But so this one's pretty obvious. I feel like this stuff's all over the news every single day. They're hugely important things. Data is pulled from the consumer, so ensuring that said data cannot get into the wrong hands or be used for malicious purposes is a huge priority. Multiple real world examples like Google, Facebook, probably any big tech company you can imagine. having court hearings over their data usage, what they do with it, who they give it to, you know, how it's all processed, et cetera, and further, you know, again, that dips into fairness and inclusivity and all that kind of stuff. It dips into all those categories because it's like, okay, what are you recording and what are you, you know, are you, what kind of data and how are you grouping this together or clustering this together, and are you creating, you know, bad AI from this or whatever it might be, or these certain data trends that you might be seeing from some certain demographic. So different, you know, strategies, you know, implementing strategies to ensure secure data usage. Like in the Azure video, they actually mentioned like local data usage, running these things locally so the customer knows that their data isn't ever sent elsewhere. I feel like for me, that would be like a huge step. I feel like most consumers, that would be a huge step to be like, yeah, your data is not sent to some scary server somewhere and wherever it might go, it goes. Is going to be a huge thing. You know, basically, yeah, making sure the consumer knows you're not creating a real life Skynet is the general idea of this. I feel like, you know, people are very, very afraid of the potential of what AI could become. With all this kind of data and information being fed into it. So this kind of assurance is like a huge factor in terms of AI acceptance. And then, yeah, further making sure that the data is not manipulated or people aren't somehow skewing the data, I guess, in whatever way, shape, or form, whether that be as a middleman or even, you know, bulking up the numbers with fake surveys or whatever it might be. And then I mentioned that there's, you know, there's things like parallels in medical science where companies fund studies that support their own stuff and then they come to find out that it's not entirely legit. So.
Absolutely. I think we're seeing just from a national and just global perspective, just a sort of increase in privacy and security, which I would actually really encourage you guys to start thinking about that. Now, I know that it seems sort of trite, but the EU just, I think I've read it today, just announced that Google Analytics, which is, I mean, how Google makes its money, is actually illegal now in the EU. And so obviously there's going to be fights and, you know, legal battles there, but we're starting to see an increase in security things. So like I use a browser called Brave, and just to give you an example, I've had Brave for 2 months, so not that long. And in the time that I have had 2 months, it has blocked 33,235 trackers from Google, from Facebook, from all these 33,000 trackers in 2 months. And so it just goes to show, and you know, I don't really scroll on the internet a lot, but it just goes to show, you know, I use DuckDuckGo on my phone because yes, exactly. Like we can have these AI tools, and Google has these Google Analytics, and Facebook is like a huge one, right? You think about Instagram and Instagram targeted ads, right? And it's a way that we have to make sure that, and when we're creating AI, we're also not exploiting people, right? That I was listening to a podcast with a lady who basically Target found out that she was pregnant before she even knew she was pregnant, based off of her searchings and based off of certain things. And they started sending articles or sending coupons basically of diapers. Or no, sorry, it was a young girl. A young girl got outed by Target because it was sending advertisements for diapers, and her parents didn't know that she was pregnant. It's like a 16-year-old teen girl. And it's this idea of like, wait, where does privacy stop? Or I was listening to another podcast where a lady was pregnant, was buying stuff for a baby, and unfortunately had a miscarriage, right? And it was this really deep, hard thing. But then she was just getting all of these ads from Facebook and all of these ads from all these things to say like, oh, buy this product for your new baby. And it was like a dagger. And she even like called Facebook and was like, please stop. This is tormenting me. And it's just all these things. We have to make sure our privacy is there and not being exploited to get us to buy a new shirt on Instagram or, you know, et cetera, we're not giving up all of our data. And then AI's basically learning and weaning us. And how do you grab attention and how do you grab all that stuff? Apple does a great commercial I think it's one of the best commercials out there about privacy. And it's basically a person goes to like a coffee shop, and then from the coffee shop, all the staff members follow the person, and they follow them around. They have all these people following them at the end of the day. And it's just talking about the same thing happens when you search, and it's, to boost Safari. But yeah, because there's cross trackers, and, this adds onto this, and that's onto this, and that's onto this. And, even if I were to show, I'm going to share my screen real fast. So here's Brave. This is it. If I were to go to just, if I go to google.com, here's, okay, so there's nothing, no cross-site trackers. But if I were to go to, like, let's say Facebook. Okay, I'm on Facebook. And if I click this, automatically there's 4 things tracking me from Google. And then if I keep adding on and I add something else, and all these trackers are following everywhere I'm going. And then they're using obviously this data and doing certain things. Oh, I wasn't sharing my screen. I'm sorry. But it can, they can follow you, and we want to make sure that, here, I'll share my screen one more time and do it again. Sorry about that. But here's Brave. This is what I use, right? But if I were to go to Facebook, I've got here Facebook, and then instantly, if I look at this, give me a second. Oh, it's because I didn't go to Brave, doesn't do it. But if I go to Facebook here, oh, it did just show 4. I'm not sure why it's not showing again, but there's cross-site trackers. And so we got to make sure that we are utilizing security and safety. Peter, you can go ahead and share again. So yeah, I use Brave for my browser, and then on my phone I use DuckDuckGo, but I think DuckDuckGo is working on a browser version as well. Just start thinking about what information's out there. Use a password manager. Yeah, that'd be my encouragement. Go ahead. Next one. Anybody else have anything to add to that? We're going to spend a little bit of time on these. Okay, cool. Inclusiveness. Anybody have anything to add on inclusiveness? Cool. I can talk about that. Just like it says in this thing, it heavily overlaps with fairness, right? They're sort of the same. We have to make sure that not only is it fair for everybody, especially if we're using AI for things like, appropriating or deciding bail time, but we want to make sure we're inclusive, and that serves everybody. That example of Apple's facial recognition technology not utilizing every people group is an issue. So we want to make sure that we are inclusive and that our technology serve people, not just a certain group of people, or it doesn't better, just one group of people. And so one of the big technologies for inclusiveness, just like this says, is Google Translate, right? And it helps with bringing in other languages and bringing in other tools. One of the tools that I'm building right now using these tools is I helped out. So I switched over to the data science team. I was part of the Python team, and now I'm on the data science team. And we have a program in Costa Rica, and I went to go help that program out. But one of the issues was, excuse me, is that a couple of the people, their predominant language was Spanish and not English. And I can understand very little Spanish, but I can speak even less of that. But there's tools, right, that Azure has called speech to text, to where on Zoom, you will be able to create and, click captions. And then the whole idea is using their technology. That way, if I'm speaking English, but their predominant language is Spanish or Mandarin or French or German, the captions will actually be in their language. And this is the idea of using AI to include people so that way they can feel, attend symposiums that are maybe in another language, or we can attend symposiums in Germany that is in German, but we can get closed captions in English or something of that nature. So it's a really cool thing. Google just came out with it. For some reason, Zoom doesn't have it. So I'm trying to build a tool that does that. But Google just came out in the Google Teams 2 days ago that they're actually doing this, and say literally the same thing where you can make captions in whatever language you choose. So there's technology in using those AI technologies to include people, so we can have a greater reach and people can learn. Cool. Next one. Transparency. Anybody want to talk about this one?
I can, sure.
Perfect. Thank you.
So transparency, just like the nutritional boxes on foods, you need to know what's inside the box, basically. Also, AI systems should be upfront about their purpose, what they're used for, how exactly they work, what data they take in, what data they keep, what their outputs are, and also their limitations. You can't have someone downloading like a simple chatting app and it suddenly has access to all your credit card and social security numbers and all. So you need to be very transparent, very open about it. This mitigates unfairness. So if we know how the code is working, then we can, look for how it's perhaps biased towards like one particular ethnic group or something. It helps developers debug and also gains more trust from users. They know, like I said, what's in the box. Yeah, especially important with apps, especially with how easy apps are to download and kids not being very technologically savvy. It'd be very easy to hide a lot of malicious things in there without transparency. Another good example is self-driving cars. They should be very transparent about how they weigh each life. Do they value the driver as more important than pedestrians? It turns into the trolley problem, kind of. But transparency in this situation just ensures moral programming.
Of is the driver more important than the pedestrian sort of thing, and understanding how the AI works. This is a big issue, and it gets sort of muggy, if you will. I don't know if you guys remember back when Donald Trump was president, he had a big issue with TikTok. And what his desire was is, I want to see how your AI, well, not him, obviously, because he doesn't know anything about AI, but basically he wanted them to open up and say, how does your algorithm work? Right. And they were like, nope, we're not doing it. And then he said, okay, you can't operate in the US unless Oracle buys you, which is like, why did Oracle? Nobody knows. But this is a big thing with Twitter and Instagram. Like, how does your AI work? How do you choose what to show? Facebook, it is a huge issue right now because, there was a probe to see if they were pushing political, if you were more right or left, does it push this or does it push that? And conspiracy theories and all this stuff from this tumultuous little 3 years we've had. How does the algorithms play a part and psychologically affect how you operate and how you do? There's a great, Netflix has a really good, it's like a mockumentary, if you will. I can't remember what it's called. I'll find it during our lunch break. But it was all about tech and how tech is sort of shaping, and it had like a real world example of, a kid and how he started, seeing conspiracy theories and how the algorithm played. And it's mood, exactly like Mara was saying, is mood manipulation and how they do that. Like that is it can be a really, really detrimental thing, and it can shift. I mean, we've literally have seen it. It has shifted like huge people groups and thousands of people to where we have people who are storming our Capitol building and believing in other conspiracies, to where, we need to know and make sure it's not just an app anymore. It's now public safety. So we have to be transparent with what we do. And exactly.
That is one transparency I'm very curious about. Like do you remember last year, like when Apple, they actually opened, for example, all of your cloud pictures, and basically for malicious pictures, right? If somebody's abusing kids or something, and that they'll report it straight to the police, right? But if that's just a doorway for other stuff, right? To see what else is there. Just like.
So you stopped it. They didn't implement it because there's so much backlash, but they basically had on your iPhones, you have technology and they could basically in one of the updates put on your phone its own like machine, basically, where it did machine learning. And what it would do, it was like a 3-part process, but the big one that had a lot of issues is it would go through all of your pictures and decide if you were looking at basically pornographic child porn. And
if you're abusing your child, yeah.
Yeah,
Something
and
like that.
and it would go through that, and then basically would flag it and say, "Oh yeah, this person does have this information." And it gave a lot of people, they didn't love that because they're like, "Oh, this is an invasion of privacy." This probably goes more towards the privacy. But another big one was if you were on the family plan, what it would do is if you had a child on the family plan that was under 18 years old, if that child sent or received an illicit picture, then the parent would be notified, hey, your child just sent a photo, that they are naked, or they just received a photo of another child with no clothes on, sort of thing. And people were like,
they really stop it?
They did, yeah, because there was so much
Really?
backlash that people didn't want them going through their iCloud.
Oh,
they felt like it
okay.
was an invasion of privacy, so they put a halt to that for right now.
No, I do remember that, but I never heard that they
they haven't implemented that.
Wow.
Yeah, they put a stop to it. But same sort of thing, right? We have to be transparent for what we do. And now I think this conversation is really, really good because I think we really see AI can be really great, but it can be really scary, and it can be, take a lot of power from people, and can be very, very scary if, so great job on the transparency. Next one. Yeah, Skynet for sure. Okay, accountability. I think this is the last one. Does anybody want to talk about this one?
I can grab this again. Accountability basically just not only programmers must take responsibility for what they create, but also their customers and their partners have to be accountable as well. So anyone who uses the software, hardware, whatever. So the example in the video was facial recognition, and the principles that guided how they operated. The accountability principles guided how they developed the facial recognition stuff, how they sold it, and also advocating for regulations, which I thought was interesting. They were very aware that their technology has the potential to be used in a really, fascist manners and such, keeping tabs on all citizens at all times, that sort of stuff. And so they advocate for the regulations. They hold these accountability principles in an effort to prevent that. And just being mindful that what they make has an impact on the world, and that they need to take responsibility for it.
I mean, all of these are huge. I feel like I've said that for all of them. But it's a big thing. There was a company who created a software called Pegasus. And basically, there's a ton of articles, and I'm happy to find the podcast. This great podcast called Darknet Diaries. If you guys are podcast people, talks all about tech and all the tools of tech and sort of the good and the bad of tech. But basically, somebody created a software that, if it was a phishing software, so they basically sent a text, and then they could track and follow all these people and get all this information. And countries started using it to track journalists who were talking bad about the country, and then people started disappearing, which is not a good thing at all. And so then there's the idea of, where is this accountability? It's on the person who created the application. They're saying that, I think it's BlackRock is the company, but they're saying like, hey, I created this, and in our clause we say, governments, you cannot use this to follow, people. It's only for terrorists, but it doesn't define, who is a terrorist. And so one, union might say, oh, anybody that opposes what are North Korea, right? You think about North Korea, anybody that opposes what Kim Jong-un says or gets a haircut that's not of one of the approved haircuts, they are a terrorist. And so, does the accountability go on the people who created the software? Does it go on the country? Does it go on the people who enact it? That's a huge, sort of conversation. And like, I love that idea of advocating for regulations, of not only, okay, I developed this, who do I sell it to? Do I sell it to a group that, has been known for tracking and doing this? And then also, advocating, hey, there needs to be regulations on how people can use the software, how people can do that. Another one for accountability, and just sort of a conundrum, would be you're driving, or you have an autonomous car, you have a Tesla, it's a green light, you're driving and you drive through the green light, and then 30 yards past the green light, a person is jaywalking and you run them over. Whose fault is that? Is it the driver for not paying attention? Is it the is it Tesla? Is it the developer? Is it the actual pedestrian who technically broke the law and jaywalked? Right. And so this idea is, and Microsoft would say the accountability should be on everybody, right? Everybody should be accountable for holding, if you're a developer, you need to hold responsibility for the product that you create and, who you sell it to, and, advocating for regulations. So anything anybody has to add to that?
I don't know how much time we have, but like there is actually like really, I don't remember the name of the show we're watching with my wife, but it's crazy something was happening there. Basically, based on all of your data, what you're searching, for example, Instagram, the posts you click, the videos you watch and stuff. And over time, basically in the movie, they were predicting if you're going to become a terrorist or you're going to be dangerous for the government or something like that.
Yeah.
Basically how you're rewiring your brain based on all the articles you're reading and stuff. And they were killing, like, for example, small kids, but imagine they'll become a Hitler in future or something like that. But basically if that AI made a mistake, you kill somebody who is actually kid. You kill a kid basically.
Yeah, that's fascinating.
But that was like something crazy. And that actually show was like from like 10, 15 years ago. Imagine what's actually going on right now.
Yeah.
In the heads of the big companies.
Yeah, no, and hopefully we don't ever get to there, because that's insane. But yeah, I think, there's a great book called Think Like a Freak. It's like an economics book, and basically it's just a great way to think and process through real world examples and sort of how to think outside the box. But one of them was a technology where banks will basically see your spending trends, and then they could, to a really, really high degree, determine if somebody was a terrorist in England, determine if somebody was a terrorist or not. And it cut down to this bank, cut it down to like 30 people who were potential terrorists based off of, their income and what was coming in and what was going out and what they were buying and where they were buying it to, or if they were sending money. And so, it's a big thing that we can, again, that comes from responsibility and privacy and sort of all of these. You can see how they're intertwined. Can make for a poor living experience if we allow it to. So anybody else have anything else to add? Cool. Well, I hope that was beneficial, and I hope that you guys sort of gained something from that, because I think it's just sort of peeling back this idea of AI and how it can affect our life. Cool. So moving forward, we got a break. We're going to do a 15-minute break. So we'll be back here at 11:05. After the break, we're going to go into machine learning. This is going to be, again, the nitty gritty. We're going to talk. So this is going to be the sort of most information and me talking through this whole course. And then we will have lunch after that. So we're going to do a break for 15 minutes. So at 11:05 PST. Or 05 of whatever time zone you're in, we will come together. We'll see you guys then. All right, friends. So now we are starting the machine learning portion of today. If you guys are from the data science team or the data science program, this will be very familiar to you. Feel free to chime in if you have anything you want to add. But if you guys haven't done that, if you come from the web development side, at the beginning, this might look like a lot, but I promise we're going to go through each piece of this. So we've already talked a little bit about what is machine learning, and it's the foundation for most AI solutions. So it's a process of a computer or machine, getting fed information and understanding patterns within the data in order to make predictions, right? And so it's just a technique that uses mathematics and statistics to create a model that can predict unknown values. So here's a video here, and let me make sure I am sharing my computer sound. Here's a video here, and it is a long, or no, this isn't the video I'm thinking of. Okay, perfect. I will play this now.
Right now, artificial intelligence helps us meet the needs of today so we're prepared for tomorrow.
By 2050, we need to produce 60% more food. So how are we going to feed the world without wrecking the planet? Using Microsoft artificial intelligence, we can reduce waste and produce more food. Any grower will tell you every row, every crop is different. We can use Microsoft AI to make local predictions about light, wind, rain. This helps farmers know when to plant, irrigate, and harvest. It's making a difference.
Artificial intelligence helps farmers grow more while wasting less.
Cool. So let's suppose an environmental conservation organization wants volunteers to identify and catalog different species of wildflowers using a phone app, right? Well, if we want to do that, then what we need is we need a team of botanists and data scientists to collect samples of wildflowers. Then the team is going to label the samples with the correct species. So if they get like a sunflower, they're going to take this image and say sunflower, right? Then we're going to take the labeled data and we're going to process it using an algorithm, and it finds a relationship between the features of the samples and the labeled species. So again, if we think of sunflower, right, it's going to find the relationship between, okay, sunflower and big yellow petals or a big, whatever the center is called, you know. Then the results of the algorithm are going to be encapsulated in what we call a model, right? And then whenever new samples are found by volunteers, the model is going to take in the image. It's going to find the different features and say, oh, there's a probability, there's a high probability that this is a sunflower because of the big yellow petals or the big round center. So that's sort of how machine learning works, right? We take some samples or we take some data, we train what we call training our model, where we process that through an algorithm. It comes out and it gives us some results. And then once that is where we seem fit and say like, oh yeah, this is a good model, then, you know, we sort of deploy it, and then people can add in new samples and it can predict those, you know, even though it's never seen maybe, you know, that specific picture of a sunflower, it will be able to predict that that is a sunflower. Now, if we didn't do this, and this is why machine learning is so big, let's say I wanted to create this app. If we didn't do this, I would have to hire a bunch of botanists. And then every time there's a request, right? What plant is this? They would then have to go and respond. It is this sort of plant. And so you can see how machine learning just helps us even create apps that are really neat. My mom, I live in Washington State, and she's from Texas. When she was up here, she had this little app that she could take a picture of a plant and it would tell her all about the plant, what the plant's name was. And she loved it. That was like one of her favorite things to do, was to see all the foliage and plants up in Washington. And that would not be possible without machine learning and without training a model. So when we're talking about machine learning, there's going to be two that we really focus on, and two that we talk about. It's called supervised and unsupervised. Now there is a third type, and it's called reinforcement learning. And that's just sort of beyond today's scope. We don't need to talk about that. It's not on the certification. It's not anything that we have to deal with. So just for the certification, we only think of machine learning as two sides, either supervised or unsupervised. And so within our supervised, section, there's two different types. There's one called regression and one called classification. Now we're going to be talking about these words. You don't have to draw this out or anything. Obviously you have access to the slides, but we're going to really dive deep into what is regression, what is classification, and how we would do an unsupervised one. Now, this is the video I was thinking. This video is quite long, and it's going to say a lot of words that, especially if you've never dealt with machine learning, it's not really going to make sense. But the goal is we're going to watch this video, talk about it, watch it at the end right before lunch, and see if we can, then be like, oh, I now understand what they're talking about. So let's go ahead. But it's about 4 minutes long, so just be prepared for that.
Machine learning is a technique in which you can use data to train a model that predicts unknown information. For example, suppose a bicycle rental company keeps records that include the weather conditions, temperature, and seasonal details for the days on which they've operated. And they also record the number of bicycle rentals that they had each day. The weather and seasonal characteristics for each day are called its features, and the thing that we want to train a model to predict, in this case the number of rentals, is called the label. For short, we often refer to the features as X and the label as Y. We can take this historic data and apply an algorithm to figure out a function that fits the features to the label. In other words, the function calculates y from x. The function we've calculated is the basis for your predictive model. So if you have the features for a new day, but the label is unknown, you can use the model to predict the unknown label, which in this case is the expected number of bike rentals. This kind of machine learning, where the label your model predicts is a numeric value, is called regression. Now let's look at another form of machine learning. This time, suppose a health clinic takes measurements from patients, including blood pressure, glucose level, weight, height, and so on. Additionally, each patient is categorized as diabetic or not diabetic. The patient measurements are our features, or X, and the classification of diabetic or not is our label, or Y. We can fit the features and labels to a function that calculates the probability of a patient belonging to a particular class based on their features. In this case, the possible classes are diabetic and not diabetic. When the features for a new patient are collected, the model we've trained can predict the probability that the patient is diabetic or not. This kind of machine learning, where the predicted label is a category or class, is called classification. So far, we've seen examples of regression, where we use historic data to train a model to predict a numeric value, and classification, where the model predicts the class to which an item belongs. These are both examples of supervised machine learning, where we have historic data with known feature and label values that we can fit to a function to train the model. Now suppose you have data that consists of features, like the measurements and petal counts of some flowers, but you have no known labels. You just want to group your items together into clusters based on their similarity. In this case, the flower measurements are our X value, and the Y value represents the clusters into which we want to group the flowers. We can use an algorithm to separate the data values into clusters based purely on the feature values, and the resulting model predicts which cluster each flower is assigned to. Clustering models like this, that are trained without a known label value, are examples of unsupervised machine learning. Regardless of the kind of machine learning model you want to create, there's a typical process that you follow. First, you need to get the data with which you're going to train your model. We call this data ingestion. Then there's usually an iterative process in which you explore the data and prepare it for modeling. Data pre-processing includes steps such as feature selection. In other words, identifying features that are likely to help predict the label and discarding others. Then you might clean the data, for example by finding outliers or errors and removing them, and imputing missing feature values with a suitable replacement. You might also engage in some feature engineering to derive new features from existing ones. And you should generally normalize your numeric features so they're on the same scale. Then you can apply an algorithm to fit your prepared data and train a model, and evaluate its performance. When you're happy with the model, you typically deploy it to a service. Applications can then connect to your service and use it to predict unknown labels from known feature values.
Okay, so a lot of that probably didn't make sense, but that's what we're going to talk about now. Okay, so we've got supervised machine learning, and that's when we have a data set with a labeled target. We can build supervised machine learning models to predict the label. What that means is when we know what we're wanting to predict, then that is what we are calling a supervised machine learning model. If I'm wanting to predict how much a house is going to cost, let's say I'm Zillow, right? And I want my people to be able to put in, how many square feet, how many bedrooms, how many bathrooms, and I want to be able to predict how much I'm going to predict the cost of the house, then I would have a supervised machine learning model because I know what I'm trying to predict. Unsupervised means we don't know what we're trying to predict. We're just trying to find similarities within our data points. So with our supervised, again, we have a labeled target, meaning I know what I'm trying to predict, and we can build that to predict that label. So the column that we are trying to predict in a supervised machine learning model is what we call a label or target. You might hear it as target as well, but we're trying to predict the label. And what we use to make that prediction, same thing like with the Zillow idea, your bedrooms, your bathroom, et cetera, those are called features, right? So what I'm trying to predict, we call it the label. And what I'm using to make my prediction is called the features. So again, this is the exact example I just have. If we have square feet, bedrooms, bathrooms, and we're trying to predict the price would be what? Does anybody know? Yeah, exactly, Peter. It would be our target or our label. So Microsoft refers to it as a label. So from a certification standpoint, sort of think about it as label, but it could also be, yes, it's a target, in the industry, you might also call it a target. So yeah, price would be a label. What I'm using to make that prediction is bedroom, right? And so does anybody know what bedrooms would be? Yep, just exactly, Jacob. It would be called a feature. Same thing, square feet would also be a feature because we're using these tools, we're using these values to make my prediction of price. And when my prediction or my label / target, when that column is of numeric value, right? So I'm trying to predict a number value of price. That is what we call a regression problem. So you can think numerical is regression. If I'm trying to predict anything of numbers, right? Whether it was the number of children somebody's going to have, or how much a car costs, or how much a house costs. If it's a numerical value, then we call that a regression problem. On the opposite, when it's a categorical value, whether somebody has diabetes or not, that would be what we call a classification problem. So if a student, so there's a great example here when we are talking about students and are they going to pass their test, right? We'll get to that here in a second. But just knowing that classification is we are grouping them into a group or a category. Now you can have 2 categories, right? Or you can have, X categories. Doesn't matter. But as long as you are trying to divide it into a group, then that would be called a classification problem. So if we're looking at this model of predicting a house price, what type of problem is this going to be if our label is price? Anybody know? Yep, exactly. This would be a regression problem, right? Because I'm trying to predict, my label is price. I'm trying to predict a number. So it'd be a regression problem. Great job. Now here, let's say that I have some features called hours slept, homework, hours studied. Here's score, right? I want to predict, that's my label. I want to see, are they going to pass or fail the exam? If I'm looking at this whole thing, what would hours studied be? My label is going to be score. Yeah, it'd be a feature. Way to go. My score is what I'm trying to predict. That is our label. So I hope you guys are starting to see, a label is what I'm trying to predict. A feature is what I'm using to make that prediction. Now, because I am trying to predict if they pass or not, what do you guys think this kind of problem would be? Yeah, exactly. This would be a classification problem because they're either in the group of passing or the group of failing. Now, one thing to note is that sometimes a classification problem could have multiple groups, but those groups are represented by a number. So, 0 represents passed, 1 represents failed, right? Although we are predicting a 0 or a 1, what we are doing, what the whole point of the prediction analysis is trying to predict which group they're in. So just be aware of that. Sometimes you can make a prediction that's either a 0 or a 1, but that's still a classification because 0 just represents, diabetic, 1 represents not diabetic. And so you're still grouping them. You're just grouping them numerically, but you're not trying to predict a numerical value. Does that make sense? Any confusion on that? Cool. Now, when we have a data set without a labeled target, right, we can build something called an unsupervised machine learning model. So that is just the main task of this is what we call clustering, right? So there's another one. And if you took our DP or our data science program, you're familiar with dimensionality reduction. So it's also an unsupervised task, but it's beyond the scope of the AI-900. All AI-900 cares about from an unsupervised perspective is what we call clustering. And so clustering is the process of grouping together similar observations and creating clusters of similar data points. So our computers will do this using unlabeled data, meaning we don't know what is the right groups and the wrong groups. We don't say like, I want you to make, these 4 groups. We just sort of give it together and it clusters points. It clusters our data into like groups. That way we can do something with it, with that. So we use something called, and something where Microsoft identifies as the unsupervised model that we use is called K-means. K-means is basically allows us to put data points into groups. And the K is so we can have as many groups as we want, whether it's 5 or 2 or 4 or whatever. And I'll show you in a bit, we use something called centroids and where those are placed. And that's how it I'll show you how K-means works. But basically what it does is it takes our data points, and we're not trying to predict anything in the sense of like how, what price a house is, or are they diabetic or not. We're just saying, I want you to group our data points and think of each data point as maybe a person. Maybe it's a profile on Facebook, or it's a profile on Instagram, or a profile Google has on you. You're saying, I want to group together like profiles. And a big thing for this would be in marketing, right? Maybe I want data points. I don't really necessarily know why or what, I'm not predicting anything, but I'm saying I want to have the most optimal marketing strategy, and I want data points that are similar. And I'll look at that and say, okay, this group is going to, I'm going to advertise to them on TikTok. This group, I'm going to advertise to them on Facebook, and this group I'm going to advertise to them on Instagram because of, XYZ, they're millennials or boomers or Gen Z or et cetera, et cetera. And so what it does is it builds a model and it groups our customers into similar groups. And again, this is a huge thing with marketing. Instagram, right? The way it would work is, let's say that Peter and I are in a group together. We're very similar. And I buy a t-shirt. What it's going to do is it's going to say, okay, somebody in this group who is similar to Peter bought this t-shirt. Therefore, I'm going to promote this t-shirt because there's a high probability that Peter will also like and want to buy this t-shirt, right? And so that's sort of how this unsupervised, one of the tools of unsupervised machine learning, how it can work, especially from a marketing standpoint, is it gets people together that are related in a way. And then it, you can, again, advertise a certain way or promote a certain product, et cetera, et cetera. So if I'm looking at this right here, we are trying to group our customers into similar groups to better individualize marketing. That's going to be what we call a clustering problem. So again, regression is we're trying to predict a numerical value. Classification is we are trying to predict a group or category that a data point is going to be in. And clustering is we don't have anything we're trying to predict. We just want to group together our clustering, or we want to group together our data points to like data points. If I go to YouTube, sorry, fat fingered. YouTube. Oh my gosh. About that. So if I say K-means example, I think I'm going to say visual. Yeah, this is the one. So here's a great example of just what K-means looks like. Right. So here I've got all these data points, right? So this is K-means clustering. I have this is just my data. I'm not trying to predict anything. Then what I do is I set something called centroids. So I'm saying I want 4 different groups, right? And so here you have this yellow, this blue, this green, and this red. The way it works is it will randomly place these centroids And then what it will do is it will identify the data points and associate them to the closest centroid. So here you can see that blue only has 3, right? Yellow has all of these, red has all of these, and green has all of these. Then once it's done associating all of the data points to the centroid, it moves the centroid to where the majority of the data points are. So it moves my data point, boom. So you see as it's moving, right, where the majority is, certain data points are no longer closer to red, they're now closer to yellow, or blue, you see now has a lot more than 3, or green, et cetera, et cetera. So then it keeps doing that until now you see blue is like has all of these, yellow has all these, green has all these, red has all these. And it gets to a point where it no longer is going to, readjust. And so now this is my group, this is my group, this is my group, this is my group. So that's where it reached our stable solution. So again, we have all these data points. We are randomly going to place, now they're placed in a different area, right? We have blue, yellow, green, red. The initial piece, right, is where, okay, blue has all of these, red has all of these, yellow has 4, green has 5 or whatever. And then it continues to readjust until it gets to our stable solution. And then now blue just has these, yellow actually has all of these, red has all of these, and green has all of these. So it's just an example of k-means clustering. And so that's just like a visual representation of what's happening there, is it's grouping together those data points. And then after that happens, then it can say, okay, I'm going to, do marketing here. And I'm going to, if one data point buys this t-shirt, I'm going to promote it to all the other data points, et cetera, et cetera. Cool. Any questions on that? On any of the supervised or unsupervised machine learning? Cool. So Microsoft Azure provides something called Azure Machine Learning Service. Now, whenever you're dealing with the certification, it is important to know these names because again, that's what you're getting certified. You're just saying, I know a general thing about AI, but then also I know that the tools that Azure is offering. So they offer one called Azure Machine Learning Service, and it's a cloud-based platform for creating, managing, and publishing machine learning models. Cool. So here, one of the main things that Azure really touts is it's got Azure Machine Learning Designer, which is a GUI, so a graphical user interface, which enables no-code development of machine learning solutions. All right, so you actually don't have to code in this. It just has a GUI, so it's sort of drag and drop and you select features. It's really, really cool. That's what we're going to focus on today, because on the exam, there is going to be some like drag and drop stuff or, what's next. And we'll see, I've got a group thing that we're all going to do together at the end that's very similar to what the exam looks like. And so it really focuses on this. So again, this designer allows us to use a GUI to graphical user interface to drag and drop machine learning tasks in order to execute a machine learning pipeline. So in this section, we're going to go over the steps for machine learning and how it's displayed in Azure Machine Learning Designer. These steps are going to be important. If you've already, again, if you're from the data science track, you absolutely understand this. If not, this might be new to you. So just, you might need to rewatch or again, our group project's going to go through these. So just understanding the process and the steps that this has and that it takes place. So that way on the exam, you might have to drag and drop into the exact steps. So in order for us to even train and to deploy using the Azure Machine Learning Designer, we need to compute. We need compute on which to run the training process and to test the train model after deploying it. So there's a bunch of different things. So basically we need the computational power to run that. So we have compute targets for our data science activities, and there's 4 types of resources that Azure has in this designer that we can use, whether it's compute instances, compute clusters, inference clusters, and attached compute. And they're all laid out right here. The ones that we're really going to focus on are our compute instance and our inference cluster. Compute instance is what we're going to use when we're training our model. And then our inference cluster is what we will use whenever we're deploying our model. So our compute instance is development workstations that data scientists can use to work with data and models. Again, that's us training our model, training our machine learning model, what is right and what is wrong. And then we're going to use the inference clusters, which are deployment targets for predictive services that use your trained model. So this is us now saying, okay, we've trained our model. It can predict home prices well. Let's go ahead and put this on the Zillow website so people can predict their home prices, to a great degree. So our first step for any sort of machine learning model is we first need data, right? If we don't have data, we can't learn and we can't train any sort of model. So we need to import our data from the web or manually. So if we wanted to upload it, or if it was some CSV file on the web, we would use that. And then this is for a supervised, sorry, I should have said this is for a supervised machine learning model. We then need to specify our target column. So we need to say, okay, this is what it looks like to bring in my data. I have brought in my data, I've uploaded it manually. And then I need to select what I'm trying to predict, right? I want to predict house prices. Within that, the next step is our data transformations. So data transformations include selecting the columns which to use in the data set, cleaning missing data, and normalizing data. So selecting columns is saying, which features do we want to use? Let's say I have a bunch of data about a person, and I need to know which columns are necessary to use and which columns are not necessary, and it can actually, make my model worse because it's now giving weight to things that actually don't matter. Second thing is we have to clean our missing data. We can't have missing data. When we're dealing with these, we have to make sure either we get rid of the row that has the missing data, or there's different ways that we can sort of clean that up. And the last thing is normalizing our data, which we're going to talk about sort of more in depth. And that's just making sure that, everything's we're comparing apples to apples, not apples to oranges. Oops. Okay. So for selecting our columns to use in the data set, this process is called feature selection or featureization, where we can choose which features we want to use for machine learning. So let's say, let's forget about the house example. Let's say I want to sell my car. I'm Kelley Blue Book, right? Now I need to train a model. I create a profile on Kelley Blue Book, and then I have all this information on my car, right? Well, I want to make sure that I am I'm selecting the right features and not just using all of them. So will the name of the person whose car it is affect the price? Well, not really, unless I'm like Dwayne Johnson or Oprah, right? Nobody's going to want to pay more because my name is Will Calhoun versus somebody else, right? So I can sort of say, oh, I don't need the name or previous owner, right? It's not necessarily going to be important, so I don't want to select that. But what will matter is my miles, right? The year of my car, my gas mileage, things like that are going to be really important. So I want to make sure I select the features that are important. I don't overfit my model, meaning I have too many columns, I have too much things, we can actually confuse and make our model worse. There's also something called feature engineering, which is just another part of featureization. That would be, let's say we want to create a column that we think would be useful for our machine learning model that actually doesn't exist. A great example would be for a car. Let's say it was, we had the miles and we had what year it came out. What if I thought it was smart to create a column that was average miles driven per year, right? So where I create a column that basically just, divides the miles by how many years old it is. And then that column now has a value of, yeah, this was driven only 8,000 miles a year. And now that might actually make my car worth more because it's not, tons of wear and tear. It was like, oh no, this was actually, maybe barely driven or anything like that. Even if you think about, right, like, let's take away the machine learning piece. If you were to go buy a car and it's like, oh, a 1960s Corvette that actually doesn't have that many miles, all original, that's going to play a part because you can say, wow, over 40 years or 50 years or whatever it is, it was actually only driven like maybe 1,000 miles a year. Because it was just, a Sunday driver or something like that. That's going to play a part versus, not really knowing, right? So even just in your mind, you can start thinking like, what would matter when I am selecting and training this model to make the best prediction? The second thing we talked about when we're dealing with data transformations, we have to clean our missing data. So we can't have missing data in our machine learning. So we can either fill the missing data with a specified value, or you can remove the rows with missing data. Sometimes if I want to fill it with a specified value, I can either put it as, it sort of depends on the column. Maybe I'll put like the mean, the average of that column. Maybe I just put that there because I'm like, it's not really going to affect it. Or if it is something that's really important, then maybe I just remove that row entirely and just say, hey, this actually isn't a great, I need these columns, or it's missing too much data. So this data point, this person of Will Calhoun didn't give me how many miles, what year it is, how many miles per gallon. They just said if it was red or blue, like that's not really a big data point. I'm just going to get rid of it altogether. Cool. Then we're going to normalize our data. And so this is going to be a really big, a really important step, because a lot of machine learning models are distance-based. So that means that they will learn patterns in the data based on basically how close. They will learn patterns in the data based on data that is close in space. And so what that really means is, let's say we have our car, information, our car deal. And I've got, a numerical value of 32, right? Let's say it is miles per gallon. And let's say my car gets 32 miles per gallon. And then I've got one called miles. And let's say it's 50,000 miles. Well, because 50,000 is so much higher than 32, right? The model is distance-based, which means that it's going to actually give more weight to the higher number. So what I can do is I can normalize my data. And the way it works is, because large units will artificially distort it, is we normalize our data and we have a scale. So there's like a min-max scaler, which is really common, to where our data is scaled between 0 and 1, meaning the lowest value in that column is going to be assigned to 0, and the highest value in that column is going to be assigned to 1. And then our data is going to be assigned relative to where it is between the 0 and the 1. So let's say I've got a card that's got 2,000 miles, that might be set to 0. And I've got a card that's got 300,000 miles, that's going to be set to 1. And then associated between there is going to be, let's say 100,000 miles is going to be set to a numerical value between 0 and 1. And that allows us to not, now if I normalize, which I would normalize every numerical value, same thing with my miles per gallon, et cetera, et cetera. Now there's not extra weight associated on the miles, or, on the miles per gallon, or how many total miles. And it now is, we're comparing apples to apples, and we're not just like distorting our machine learning model because one is, in the thousands, and that's to be expected with total miles driven, and the other one's in the, sub 40 because, cars only don't get that much unless you have an electric car. Cool. So we have taken our data, then we've selected the columns. We've selected the columns we want to use. We've cleaned our missing data, and we've normalized our data. Great. And the way that you would do this, and it might show this on the platform. So this is how you would do it, like actually on the Azure website, is basically you would have these columns, right, that you've uploaded, and then you would make a selected one, right? So I want to select all of these columns in order to train my model there. So I've done that. I have taken in my data, I've selected my columns, I've cleaned my missing data. And then once I'm done cleaning, I want to normalize. You want to normalize at the end. I select my columns, I figure out what's missing. I either appropriate that and however I want, or I get rid of that data. And then I go and I normalize that. And so again, same thing. If I want to clean it, I can select my column names. And then how do I want to transform them? Here it is. So I can do like with rules, I can do a bunch of different things by transforming my columns, and then I normalize it, right? And that's what this idea behind transforming is. I normalize my data. If you look at this, here's all the highway miles per gallon, city miles per gallon, peak RPM, symboling, horsepower, width, length, engine size, curb weight. See how these are all numerical values. I want to transform those to maybe like a min-max scale, to make sure that now we're comparing apples to apples, and it's just a numerical value in relative to the highest and the lowest of that column, not again the thousands versus, highway miles per gallon is gonna be like 15, right? Something of that nature. Then after we've done that, so we've added our information, we've done all that information, we've selected, we've cleaned, we've normalized, then we actually train our models. And this is the actual process of allowing our model to learn patterns within our data set in order for it to make its prediction. And right before we train it, we actually want to split our data into a training and a validation set. So like test, train, split, if you guys did data science, to where we want to take our data and we want to take a portion of it, and I want to train my model on this portion, like 75%, let's say. Then I'm going to save 25%. And what that's going to allow me to do is it's going to train my model, and I'm going to see, okay, how accurate is it? It's trained. Okay. Then I'm going to introduce it to new data and say, with stuff it's never seen before, how accurate is it? Right. And so sometimes those can vary, and I can adjust, my features, or I can adjust different things. And so same thing here is the purpose of building a machine learning model is to predict a new/unknown value. So we need to hold out some of our data and to be able to evaluate it and basically compare it to how well it did on the stuff that it has seen with the stuff that's unseen and the data it actually has not seen. Cool. So so we split our data, right? Now I've got my training data and then my testing data. Then what I'm going to do is I'm going to associate the model I want to use, the module, sorry, that I want to use. Basically, what is the algorithm I'm using to actually train my model? And so this is from the Microsoft perspective. So on the exam, these are the three that are associates with. If I'm using if I'm using regression, right, I'm trying to predict a numerical value, it is going to be a linear regression module that we are using, right? That's the algorithm we are using to make our prediction. Now, here's a point of confusion for a lot of people because it's got the word regression in it. But for classification, we actually use something called logistic regression. And that just is going to create a probability of a category, and whichever one, then it focuses on that. So it has the word regression in it, but logistic regression is actually for our classification models. And then last one that we've already seen for clustering, we just use k-means. That is what that's the module we're going to use for that. So we pick, okay, what are we trying to do? Which one are we going to use? So again, for linear regression, it just creates and predicts this numerical value. So there's the data point, and it uses regression on what is the similarities and what are the trends that we have, and where is it going to go from a predictive standpoint. Again, my logistic regression returns a probability between 0 and 1 of being in the positive class, so 1, or being 1, or negative class being closer to 0. And this is great for binary classification problems. So whether they have diabetes or not, whether it's malignant or benign. Now you can do it with multiple, it's a little bit more steps there, but from a Microsoft perspective, we just really care about the binary classification problems, which just means 2 groups, right? And that's all that it focuses on for the certification. And the last one is the k-means clustering. And we've already talked about this. This just shows that we create something called centroids and n-dimensional space, right? Then all of a sudden, this is what we visually saw, where the centroids move to the different points, and it moves to the main point, or the main cluster of those points, and it continues to move until we stabilize, right? And we have a stable solution to where, okay, no matter what, it's not going to move. And now these data points are associated with this cluster. So we've split our data, we've picked which module, and then we actually train it, right? And so once we're done training it, that's us giving it information and it's learning. Now my machine is learning, okay, what are some similarities? What are some different things with our data points? After it does that, after we train it, then we score it, right? And we say, okay, how well did it do? Which basically says, how does our model perform on the validation set? So on the stuff that we held out, on the stuff that it's never seen, how well does that perform? And then we choose the best performing model so we can tweak it. We can do different things, adding different columns, right? Saying, okay, maybe I don't need the weight of the car. Maybe that sort of affects it. Like, how does that work with that? Or like Peter asked a question where we can We can add weight to different features if we wanted to, right? So I can mess with that and associate that and see, okay, what makes it perform the best? If I've got, 4 centroids versus 3 versus 6, what is the most optimal, and what is the best? Well, not really the centroids one, because you don't necessarily score that, but what is the most optimal way that I can do that? And I can do different things in order to sort of increase or change. And so with our scoring, we can use something called cross-validation, which iteratively is picking new validation sets and scoring our model on each of these validation sets to see how our model performs on the unseen data sets, which is sort of, changes that up. That way we can see, okay, what is the most optimal version of this model? So here's a visual representation of all of those steps. We get our data, we select our columns, we clean our missing data. This is another thing you can go in and change, right? Whether if you have a lot of data points and maybe you use one thing to fix the missing data points, whether I want to use the minimum or I want the mean, that's another way that I can go in and say, okay, I use this. What if I use this? How accurate does it, what if I change the way that I clean this data? That'd be another way to do it. Then we do these 3 steps. We split our data to our test train split. We pick which module we want to use. We train our model, right? We pick which algorithm we're using. We train it using our training values, using our algorithm. Then we take that value, we score it, and we give it the data it hasn't seen before, that data we set aside. And then lastly, we evaluate it. So we choose an evaluation metric to see how good of a job our model does at correctly predicting our target. So from an evaluation standpoint, there's quite a few we can choose from. For regression models, we use, there's quite a few. There's mean absolute error, where it's the average difference between predicted values and their true values. Now it's whether you're 10,000 over, let's say we're predicting a house, whether you're 10,000 over or 10,000 under, it's just taking the absolute value saying you were off by 10,000, right? Whether you're under or over, that's what you were off. Then you have the root of the root mean squared error, where it takes sort of the difference, but then it squares it and then takes the square root of that. Or the same thing of the predicted values. So that's just another tool that we can use. So when compared, a larger difference indicates a greater variance. So if I'm off by 10,000 or 12,000, it generates a greater variance for that. Then I've got the coefficient of determination, commonly referred to R squared, and summarizes how much of a variance between predicted and true values is explained by the model. So the closer to the one the value is, the better the model is performing. So that is from a regression standpoint. There's also for the classification metrics, there's the confusion matrix. And so this is a tabulation of the predicted and actual value counts for each possible class. So this is for binary classification model. When you're predicting one of 2 possible values, the confusion matrix is a 2x2 grid showing the predicted and actual value counts for the classes. So if I predicted a 1 and this was actually 1, perfect. I have 869 that I predicted was going to be 1 that are actually 1. I had 342 that I predicted were going to be 0 or 1, sorry, that are actually 0. I had predicted 612 were going to be 0, but there were actually 1. And here I've got 2,677 that are predicted 0 and are actually 0. And this is just a great example of, I think it was Jacob that was talking about predicting, cancerous cells. If I predict 0, right, and they actually do have cancer, they are actually cancerous, this can be really scary, because now 612 people are thinking that they don't have cancer, they leave, and that cancer could continue to grow. So there's other ways from a classification standpoint. You've got accuracy, precision, and recall. And so accuracy is the ratio from our confusion matrix, the ratio of correct predictions, which is true positives, meaning we said that it was positive and it was positive, and true negatives. So we said that it was negative and it was negative. right? We said that it was going to be 0 and it was 0. We said it was going to be 1 and it was 1. To the total number of predictions. So what proportion of diabetes predictions did the model get right? Whether it's, they had diabetes or not. Then you've got precision, which is the fraction of positive cases correctly identified. So the number of true positives divided by the number of true positives plus false positives. So again, when we said that it actually was, we predicted 342, but that's a false positive, right? Because it actually isn't. That's what that's talking about. So out of all the patients that the model is predicted as having diabetes, how many of them are actually diabetic? And then the last one is recall. So the fraction of the cases classified as positive that are actually positive. So the number of true positives divided by the number of true positives plus false negatives. And that's this guy right here, right? Where we said it was negative. It's a false negative. We predicted it's going to be negative, but it actually is positive. They actually do have, cancer or diabetes. So in other words, out of all the patients who actually have diabetes, how many did the model identify? So those are the different sort of metrics we can look at. There's also a couple others, the F1 score. So it's an overall metric that essentially combines precision and recall. Then you have the AUC. Now the AUC is going to be big with logistic regression, where it creates the ROC curve, right? And we look at the area under it. A big thing to really know about the AUC is if you use the AUC to evaluate, if it's lower than 0.5, that means your model is actually worse at predicting than randomly guessing. So you're what that's basically saying is your model is trash, because you would be better off randomly guessing if this person has diabetes or not than using your model, which is not great. So with your AUC, anything above 0.5, right, is obviously better than guessing. So 0.6 is better than guessing, but anything below 0.5, you are literally performing worse than randomly guessing. And then when it comes to evaluating clustering evaluation metrics, the certification doesn't sort of deal with any of that. So you don't have to worry about that. So we do in data science, there are some evaluation metrics that you can use to understand how good our clusters are. But largely unsupervised models don't have evaluation metrics, so you don't have to worry about that. So we score our model, we evaluate, and then once we are done, we create. So we've done all that, we've evaluated. Then I create and run a pipeline to train the model. So after creating and running the pipeline, that's what we did to train the model, you need a second pipeline that performs the same data transformations for the new data, then uses the trained model to inference, in other words, predict, label values based on its features. This will form the basis for a predictive service that you can publish for application use. So we basically train it. Then we say, okay, now I want to go ahead and put this onto the website where I've got a web service input, meaning my user has inputted some data, right? So they can go to Zillow and they can say, I have this many bedrooms, this many square feet, this many, bathrooms. Then it goes and it uses our selected columns, right? It uses that information. Then it uses our cleaning to apply the transformation. So it uses the steps that we've already taken, that we've identified, and it assigns that to the data, right? So if I don't put a car, if I don't put, if I don't put a bathroom, or if I don't put XYZ and I've associated that, it goes and it trains that, normalizes as well. Then, this is the normalizing part. So then it normalizes it. So it cleans our missing data, it normalizes our data. Then what it does is it does our train model. So it takes our train model, it runs that value, and then we score it, right? And then we execute the Python script, and then we give them an output, meaning that everything that we've done for the previous pipeline, it does that to the new data, and then it evaluates an output of your house is now going to be worth blank, or your car is going to be worth blank, right? So this is just an inference pipeline. This is a deployed model on, let's say, Zillow or something like that. Any questions on this? Cool. So what I'm going to do is, this will be the last thing, and we're going to go to lunch. Shouldn't take 5 minutes, and then we'll go to lunch. This is just an idea on the actual exam. on the actual exam, you know, there's a lot of drag and drop. It's not going to be as empty, but a couple of these might be missing and they're going to have to drag and drop, you know, where these go. So I just thought we could do one for classification and one for clustering, just to make sure that we are all on the same page. So we're just going to do this as a group. What would be first? What's the first thing I have to do in my pipeline? You guys can come off mute or you can just write it in the chat. First thing I have to do for my pipeline.
The diabetes data.
Yeah, you got to get the data first. Exactly. Right. So I've got to get the data first. Then what am I doing? Now, this one, I'll kind of give you this answer. We're doing our data transformations. This one just says normalized data, but that would be our data transformations, right? We are taking the data, we are cleaning it, we are normalizing it, we're selecting our features. So this normalized data is more so, you know, cleaning and transforming. Yep. Then I've got, well, not train model quite yet. What do I got to do before I train my model? There's 2 steps.
Split data.
Split data. Yep. I got to split my data into my train test split. And then what else do I have to do? This is a classification problem. I also have to choose what?
Logistic regression.
Yeah, I got to choose what am I actually going to use for this. So I'm going to choose, I'm going to split my data. I'm going to choose the algorithm I want to use. Then Jacob is when we're going to train our model, right? On our data, on our training sort of data set. Then from there, what am I going to do? Am I going to score it, then evaluate, or evaluate, then score? Okay, then I'm going to score. Thanks, Jacob. And then lastly, like you said, we then evaluate our model. So we get our data, we transform it, we clean it, we select our features, and we normalize it. And we split our data into our train test split. So we have a portion that we're going to train it on, portion that we're going to test it on. We choose our algorithm, we then train it. And then after it's trained, we compare it and score it on how it does with the data it didn't see. And then we evaluate our model. Cool. This one's a little bit more difficult, but let's see if we can grab this one. This is our clustering one. Oh, I gave you one on accident. Whoops. Didn't mean to. Okay. So what's the first thing I got to do here? Anybody know? Right here, first thing. Yep, just like you said, Jacob, we're going to take our penguin data. Then what do I want to do? Yeah, exactly. Exactly, Rick. We're going to then select column. Oh my goodness. What's happening? I don't know. There we go. Then I'm going to select my columns. Then I'm going to clean it. Then what am I going to do? Selected my columns. Yep. I'm going to normalize. Where'd it go, guys? Then what? Yeah, I'm going to split it. The split go here, here, right or left? Right. Yep. Perfect. Then what I want to do? K means left. And lastly, we train our clustering model. And then after that, it assigns data to clusters. Way to go, guys. So this is just an example. I'll send you this if you guys wanted this for your, this is being recorded, but if you guys wanted this for your sort of studies, you can. Cool. Okay, so that is lunchtime. Are there any questions before we go to lunch? Cool. Well, if you guys do have any questions, just feel free to, put them in the chat while we're all at lunch. We will be at lunch for 1 hour. And so we'll be back here at 1 o'clock. I hope you guys have a great time.